Hello, everybody, and welcome to today's session where we will be talking over ACE 1306 and what is new. And with a bit of luck, we should be seeing today's agenda chart, which goes into some of the detail of the features that we will be discussing. As usual in these kind of presentations, I like to be very heavily weighted towards the demo side. So we're going to have roughly half of our content today being demonstrations, and they're the best kind of demonstrations because they've been pre-recorded. So we are 100% sure that they're going to work, assuming we can get the webcasting technology to work. So what you'll find during those sessions of the presentation, those various parts, you'll hear my voice, but it is a pre-recorded version of me. And then I will return to you in between each segment and queue up the next ones and talk through the items that we'll be covering via PowerPoint as well. So the vast majority of the features we'll be talking about today are already generally available. There are some features which are currently covered as so-called technology preview features. These ones are available for anybody who has entitlement to App Connect Enterprise to download and try out, but they're not yet supported in a production environment. Those very few features are all in the arena of ACE Agentic AI and MCP tools. So we'll be talking about those towards the end of the presentation. I'm going to go in chronological order today. So before we get to those items, I'm going to start with the items that come as part of the 13060 deliverable. And that one came to market at the end of December, at the very end of last year. And we're currently working away very hard on the 1307 release, which should make it out to the outside world around about the end of March. So without further ado, let us crack on and talk through these features. And they're in various different areas of the product. So before we dive into the first one, I just wanted to position what ACE 13 is all about. So I'm sure that many folks would have seen this chart before. I'm not going to spend long on it. Suffice to say that the 13 release, which has been out since September of 2024, covers a few major kind of themes that keep coming back to us. So a large focus on connectors. We'll be talking about a few new discovery connectors that have been added in 1306 later today. And there's also been a feature on some of the core components of ACE over that time period. So ACE 13 was the first version of ACE to ship with a Java 17 option. And as part of that deliverable, I'm hoping that some folks may have seen a recent statement of direction that we put out regarding the last part of ACE 13 that needs to be changed in order to support Java 17, and that's in the area of WS security. So if there are any SOAP users out there that are users of WS security and wanting to start adopting that within a Java 17 based integration server, that one's coming to us very soon. The column on the far right of this chart is referring to some of the different ways in which we make the ACE technology available to users. So we offer part of our software platform is an install that goes into a VM or into a traditional LPAR directly installed on Metal. Then we also have our container offering, and specifically some of the AI features that we talk about today, they will be related to that container offering. So that's probably enough on the overview. I, again, always put up a quick life cycle chart just so we can talk about some of the dates. So ACE 13 originally came to market in September of 2024, and then every quarter since then, we've had mod releases with new features and functions provided each quarter. And so we'll be talking today about all of the content in 13060, and we'll expect those continuous releases of new functions each quarter to continue through the rest of this calendar year. And by the time we're into 2027, we might be expecting, if we look into our crystal ball, perhaps later that year towards an ACE 14 major engineering release. At this point, completely unannounced, all still subject to change, but that's the normal kind of cadence. And you can see that with the stepped variety of this chart, where we've moved on from ACE 11 to 12 to 13, typically every 3 years. So that's the product life cycle. Let's dive into ACE 13, and in particular 13060. Each one of the items that are shown on this chart we'll be diving into in more detail as we go through the presentation, with one exception. I've placed on here the IBM App Connect for Healthcare deliverable. That is actually a deliverable in its own right. It's separately entitled, it's separately licensed. It is designed as an accelerator for those users who want to use ACE, but within a healthcare context. So in particular, if there's anyone out there that wants to do HL7 messaging, that wants to use FHIR processing with the FHIR standards, and doing that on a basis of an ACE 13 runtime, then I'm sure those folks will be very interested in hearing more about IBM App Connect for Healthcare. That was an entirely new release that's just come out, and as I say, it's probably one that's needs a dedicated session in its own right, as opposed to the more generalized users of ACE. But I wanted to make sure I gave that a quick mention up front. The other features, as we go around this chart, we will focus on with individual demos and individual pictures and explanations. So we're going to start off talking about some of the features that have come into our designer offering. ACE actually has two different authoring tools. One of them we refer to as Designer, which is our web browser-based offering, and the Toolkit, which is our traditional Eclipse-based tooling for our integration specialist. And we're continuing to put new features into both of those, and we'll be using them both throughout the demonstrations that we see today. And the first one of these particular features is in relation to our Designer tooling in particular, though. So our designer tooling has, for some time, provided an immense breadth of different connectivity options for a huge variety of third-party services and SaaS services in particular. We've also got some basic technology connectors that sit inside that offering that enable you to exchange messages via queues, for example, or via HTTP communications. And the designer authoring tool itself started life up on the public cloud, but it's now shipped and is available as part of an on-premise offering. So you can still install that just on a local developer's laptop and their workstation. With that in mind, we've added into that software deliverable of Designer the ability to import an open API definition so that you can create flows that are then used when communicating with those third-party REST API systems. And so we're going to see in a moment, when we play up this video, an example of doing those imports with a couple of different open API definitions, which we will then use to invoke those external services. We're actually going to host those external services within ACE itself as well, and we're going to do that courtesy of some toolkit flows. So aside from that brief introduction, I will get my colleague Aditi to play up the first video, and the next voice you'll hear will be me with a video demonstration of importing open API definitions.
The local ACE integration server shown has two REST APIs secured by HTTPS. The Customer API and Loyalty Card API can be used to discover information about a fictional supermarket and its customers. Customer API offers 5 methods, but we're particularly interested in the GET operations to retrieve all customers or a specific customer using a customer ID. Not all customers are members of this store's loyalty program, so the Loyalty Card API provides function to query which customers are registered. Opening the ACE Web UI, we're going to start by trying out the REST APIs, and after this we'll move to the Designer authoring tool to show how to quickly create flows which can invoke these APIs. Retrieving all known customers, you'll see there are 3 customers who coincidentally happen to share names with famous ex-Tottenham Hotspur footballers, Harry Kane, Gary Lineker and Jimmy Greaves. Each customer has a unique number as its ID. The Loyalty API operates in a similar way, except when we query the customers registered, we only receive 2 responses for Harry and Gary. It looks like Jimmy hasn't yet signed up for the loyalty program. Switching to the Designer authoring tool, we're going to build a scenario around invoking both the Customer and Loyalty Card APIs. After providing the Vault key to log in, we will create a new REST API flow in just a moment, but we'll start by running a discovery process to teach Designer about the 2 APIs we wish to invoke. The Applications and APIs page loads a catalogue of available back-end third-party services which we may want to connect to. There are previously configured accounts for MQ and Salesforce, but we're going to click the New button with the plus symbol to add a new API. We're navigating the file system to locate the Open API document for the Customer API, and on clicking the Next button, the document is read and we can see the available objects and actions that it contains. As you'll recall, the Customer API has 5 operations in total. When that import process finishes successfully, the Customer API will now be listed in our catalogue. We're now going to repeat that process for the second API representing the loyalty card information. The final flow which we construct will invoke both Customer and Loyalty APIs in that order, using the same customer identity in order to figure out their current overall status. Clicking the blue button to import the API finishes the import process. The resulting APIs are now added into the catalogue list of available endpoints, and whilst we've provided a definition of how the APIs operate, we haven't yet provided any connection information to the system where the APIs are actually hosted, which is exactly what we'll do next. There are options to provide a username and password, but we don't have basic authentication turned on in this simple example, so we can ignore those fields and complete the connection. The connected applications now include the Customer API alongside MQ and Salesforce. We're now going to navigate down and repeat the process for the Loyalty Card API. The only change we'll make here is to, again, repeat the setting to allow self-signed certificates, and then hit the Connect button, and we've successfully connected the Loyalty API as well. For this reason, you can now see there are 4 connections in our connected list. We'll now start the process of creating the actual flow, which will exploit the 2 connections we've just made. We're going to create a flow for API, which requires us to have a model to describe the inbound-outbound data. We're going to call this our supermarket customer model, and we're going to pass in a customer ID to uniquely identify the customer that we're querying. We're also going to have a message property, which will provide some response information. We're going to implement a flow for one of the actions against this model to simply retrieve the supermarket customer by ID. Adding in a REST request option, we're going to select the customer API, and in the where clause, we will pass in the customer ID that came into the initial query that drives this whole flow. We'll then add a second loyalty card API REST request. And this time, when we navigate through to the action, we'll repeat the input value from the request URL parameters containing the customer ID a second time around. The last job in our flow is to take the information from both of those 2 REST requests and include it within the final output. The field in the output data called message will contain both a response from the customer API followed by the loyalty card API, with 2 separate values being provided into the field. And that completes the very simple process of authoring the flow. What we're now going to do is use the designer's inbuilt function to test out that API. We're going to try a few different values. Navigating to the Test tab at the top of the page and then selecting the Get operation that we defined in the flow, we can then move to the right side of the page and select the Try It tab, where we'll have the option to provide the input data for the flow invocation. We're passing in the customer ID number 1, and examining the response message, we can see that Harry Kane has been located. He is a member of the loyalty program, has 280 points in the gold membership tier, and his home store is located in Munich. Trying out a second ID, number 2, we get very similar information back. Again, we see that Gary Lineker is also a member of the loyalty program. He has a different number of points inside the silver membership tier. The third piece of data that we'll use to invoke the flow has customer ID number 3. This time things are slightly different. Jimmy Greaves has been located as a known customer, but no loyalty card has been found with his loyalty card ID, which shouldn't be surprising given the values that we saw at the very beginning of the demonstration. The final flow invocation with ID number 4 finds that no customer exists with that ID, nor is their loyalty information either. So in conclusion, this demo has shown the invocation of REST APIs imported into the Designer authoring tool.
Okay, welcome back. That told us all about the use of the Designer tool for importing OpenAPI definitions. And we will now move our attention onwards in a somewhat affiliated area, actually. So alongside that new Designer feature that we just demoed, we also have the option of support for using OAuth 2's authorization framework when we're making outbound REST requests in order to communicate with external REST APIs. Now, for those that aren't aware, OAuth 2 is an authorization framework, and it allows third-party applications to access protected resources on your behalf without the need to actually directly share your credentials. So in the context of REST APIs, OAuth 2 is essentially delegating the access, the ability to secure that access to an authorization server. And that authorization server then grants you the tokens, and then those tokens are presented by the application, and on the grounds of what that token says, that the person's allowed to carry out an action. So this is a much cleaner way than worrying about using passwords or traditional kind of authentication mechanisms. The bottom left corner of this chart summarizes how that process works. So in this particular example, ACE is actually acting as a client application, and the access token is being provided by the authorization server, and that then needs to be presented by the ACE REST request when it attempts to go off and invoke that third-party API. Now, when we come to implement OAuth 2 and the OpenAPI document that's involved here when you're using a REST request, you'll actually have a set of security schemes, maybe one, maybe more, defined inside that OpenAPI document when you go through the import process that we just saw in the scenario video that we stepped through. And these schemes are providing a bunch of available options that can then be exposed by the ACE Designer tool based on a drop-down. You can see the authorization type drop-down that's appearing in a couple of the screenshots that are on the chart here. So the basic OAuth option, which is shown in the middle of the screen, is one example of these new auth types. There are a few different ones. So you can do basic authentication still. You could use an API key. You might be using a bearer token, or in the case of basic OAuth, you might request from the user multiple different pieces of security information. So for example, they might provide an application client ID, a client secret, and then ultimately an access token and a refresh token as well. And with that basically summarizes what can be quite a turgid subject in terms of presenting it and demoing it, but quite a good step forward there that we've now got this full OAuth 2 support when we're using that REST request situation within an outbound flow. So moving on, let's talk about the next topic, which again is somewhat connected to the one that we were just talking about. So here we're talking about the option of using an HTTP proxy from the Discovery connector nodes that are placed within a designer flow. And when you're deploying software on premises, particularly integration software, enterprises might choose to deploy an HTTP proxy server between their internal users and their applications, and then those external connections that they make to the internet. So this can be useful for blocking access to specific websites, if you want to cache particularly popular web pages so they can be provided to your browsers faster, and maybe in some circumstances also for security reasons, such as filtering out malicious kind of content. So ACE Toolkit message flows that have been deployed into an integration server have historically catered for giving these kind of connections through an HTTP proxy. We've got a few different examples of that. So we've used the HTTP request node, the REST request node. More recently, we expanded that kind of approach to our Salesforce request node as well. But now we have this whole plethora of additional discovery connectors. So in ACE 13060, we've introduced this similar capability when you're making these connections to these third-party applications from designer message flows. And the way that's done is to actually support the use of a proxy both at flow authoring time when you're doing discovery, and then also at the flow runtime when you've got the flows deployed. So to use an HTTP proxy connection from Designer, what you do is to begin with, you navigate to the connections section of the main menu, which is shown on the right side of this chart. And then you would select the HTTP proxies option. And here you'll get given a tabulated view of all of the existing proxy connections that you've previously created. At that point, you can select one of those or you can create a new one. And when you create a new proxy connection, you'll need to provide the tool with the proxy URL, your username, and your password for accessing that proxy server. And having created that proxy connection, you can then reference to that when you connect to several different applications. So you can see along the bottom of the chart, we've got a very long list now of those third-party applications which support this use of an HTTP proxy. When you're going through discovery against one of those applications, you can then nominate the proxy information, the name of the proxy server configuration that you've previously created, using the method that I just described. And then when we make the connection, we will go through that proxy in order to communicate with that backend server. So in summary, then, a really good extra security option for those users that are sitting behind a firewall that have a corporate policy that mandates the use of a discovery option via an HTTP proxy. Again, continuing on that theme, we talked a lot there about different connector types and how we can secure those connections. So in the toolkit this time around, we've added some new discovery nodes. And these discovery nodes are continuing that theme that I referenced in my introduction of constantly expanding all of the different kinds of applications that you can connect to. So you can see we've listed out here several different applications and what their raison d'etre is in the universe. Why do they exist and what do they do? So if we talk through a couple of those examples, the Apache Pulsar request node enables you to issue requests that can perform actions on objects such as message publishing and message subscriptions. If we're talking about the Astra DB node, that one gives you kind of the create, retrieve, update, and delete of objects, like many of the discovery connectors. And there we apply that to both Astra DB collections and documents. In the case of Databricks, we've got an input node and we've got the request node. And there we do things like monitor the Databricks tables for new events and then generate a triggered input at the beginning of a flow or reach out to that tables in the middle of a flow. And we've also got the SAP SuccessFactors input node, and we previously already had a SAP SuccessFactors request node, so that's rounding out the support there in the area of SAP SuccessFactors. Also shown on the chart, we've got an example of a policy. So each one of these new connectors comes with it having a new policy type to back up the configuration that you'd require when you're talking to that third-party system. So whenever we add one of these new connector discovery nodes for either input or request, we have the policy that goes alongside of it. And you can see an example here. I've just plucked out the Apache Pulsar example, which shows you the various URLs that are needed when we talk to that system. So no excuses. If there's an application that you think we need to add to the product, please do let us know. We're always interested in new ones. We're ever expanding that list of connectors. So if there is something that you'd like us to get on with, then please do let us know through the usual process, going through an aha idea. But hopefully we're keeping pace with this brave new world now where lots of connectors are needed. So shifting focus in a moment towards our next demo, we're now going to talk a little bit about the ACE toolkit and one of the new features there for improved usability around the policy editor. So I mentioned policies a moment ago with regard to how we connect to third-party applications. We use policies across the board. Many different policy types now exist. And so what we've done in this particular release of ACE is to try and improve the look and feel of that policy editor. So what we're going to see in the example here is the usage of some new description fields that appear within the policy editor, and also a new way of displaying related properties. So we're going to see an example of using a little twisty inside the policy editor to bring together related properties of a particular type. So Aditi, when you can, if you could launch us into the next demo, again, you'll hear me audio commentate on it, and then it will return to me when the video completes.
This quick demonstration explores some usability enhancements for the toolkit in ACE 13060, which make it easier to work with policies. This demo uses an integration node, and we can see there's a variety of artifacts that have been deployed to the servers owned by that node. And in the toolkit here, we're now going to create a new policy named example policy, and we're going to select the activity log type. Within an activity log policy, you can choose the minimum severity of the log entries that you would like to be inserted in the activity log which is saved. In the file name property, we're choosing to type the name of a file that we're going to write these entries to on the disk system. Of particular interest in this demonstration is the new description section, which is now placed at the top of all of the different policy types. It consists of a version field, a short description, and a long description. In various other places, individual policy types have also started grouping properties together within twisties that look very similar to the description one that we're looking at here. Having defined our policy, we're now going to deploy the policy project to server 3, and then we're going to examine the effects at runtime. Bringing up a command console, we can run the MQSI list command with a low level of depth to recursively look within that server at all of the artifacts and their properties. We can see that version 1.0 of our policy has already been deployed, with its short description and long description copied through, and crucially, to begin with, there are no keywords associated with that policy. We're going to return to that command in just a moment, but before we do so, we're going to simulate the process of a user updating and redeploying the policy. They've now labelled it as version 2, and this time around we're going to use the $MQSI keyword syntax in order to apply an author property to this particular policy using the short description field. We can also change the description in the long description and one of the properties of the policy so that we start gathering in activity log at a different level of severity. When we redeploy the policy, we can then return to our command console and see the impact of those changes. Repeating the MQSI list command shows that now we have assigned version 2 in the metadata for the policy. We've also got the updated descriptions and now a dedicated keyword where the author has been recognized as Ben Thompson. In summary, our quick demo has shown the new description fields on policies and how to exploit them for improved admin and reporting.
Okay, so there was our second example demo. We will now move on to the next feature. So we're going to stick in the area of Toolkit for a moment and talk about a new retry capability that we have for the Toolkit REST request node. A couple of months back, you may have seen a similar webinar to this one where we spoke about a very similar feature to the REST request node that I'm talking about here, which we added to our HTTP request node. And in both these cases, this feature essentially allows these nodes to more easily cope with situations where you have very brief problem with a network connection to a third-party system. So this allows you to do an automatic retry based on a return code that you might get back, which could be an HTTP status code. It could alternatively be a POSIX socket code, a POSIX error code that comes back. And you can see in the table that's shown in the bottom left of the chart, we've got those two options which you can select from, various different numbers of those different codes and the different descriptions. And based on the ones that you select, if you've chosen to turn on short retry, we would then attempt with the interval specified in the other properties to retry that same system again. So if you're interacting with some third-party systems, you want to try quickly a few times over, maybe a few packets have been lost on the journey, it's a nice quick way to get that up and running. So without further ado, we've got plenty more to get through today. We're going to move to our next demonstration. This is another Toolkit feature, and this time around, this is going to involve our Toolkit scheduler node, which is essentially used for triggering a message flow with events on a timed basis. So we're going to see this in action. It's been a part of the product for a while now, but what's new here is the addition of a state persistence policy that allows us to be reactive to events that happen while ACE is not actually running. So with that introduction, Aditi, whenever ready, if you could please play the next video.
In this recording, we're going to demonstrate some new capabilities in 13060 for the scheduler node. In this example, we have an interval of 5 seconds set up, and on the Advanced tab, we have some further settings that show how we can now interact with a state persistence policy. The state persistence policy has a couple of alternatives. You can use a persistence type of file or Redis. In our case, we're using file, so we've provided a directory for its usage. Returning to the flow, the scheduler node has a missed event mode property, which to begin with is set to none. When we deploy the application, you can see that the flow is triggered every 5 seconds, with the compute node generating a brief message written to the output file, being tailed at the bottom of the screen. A new line is added to the file every 5 seconds. As I'm talking, we're then going to restart the integration server and watch what happens to the events being generated. The detailed entries in the file are noting the time in the compute node and the time when the scheduler node propagation actually started. Typically, these steps are a few thousandths of a second apart, and these values will be useful to us when explaining some behavior later on. Now the server is in the process of starting up again, I've manually inserted a couple of blank lines into the tail output so that it will be easy to identify what is written to the file after the restart completes. The success dialog is going to show that the server has been restarted again, and the messages will appear at 5-second intervals just like before. Note that there was a dead period whilst the server was stopped of about half a minute, from 7 minutes 44 seconds to 8 minutes 21 seconds. During this time, no new events were generated, and when the server restarted, there was no event catch-up occurring either. We're now going to amend the flow and change the missed event mode to be all. When we then redeploy this to the same integration server, we'll notice the change in behavior. The deploy takes a few seconds, but is significantly quicker than the server restart, and you'll notice that after the flow deployed, the first couple of events show a slightly larger time difference between when the flow was scheduled to start and when it was actually running. With the brief pause for a redeployment, things are quickly back on track with the 5-second interval, but we will be able to see more clearly what's actually happening here with the catch-up of generated events if we do another full server restart. The message at the bottom right of the toolkit shows that the server is now in the process of being stopped. Once completely stopped, the toolkit will immediately restart the server, and that whole process, just like we saw a moment ago, is likely to take us around 30 seconds. When the server restarts, you should notice a sudden rush of 7 or 8 events appear in the lower window, as the integration server will attempt to catch up with the scheduled events that otherwise would have been triggered during the period whilst the server was stopped. The information we're logging should show that even though these events all occur very closely one after the other, as soon as the server starts, their scheduled start times will cover the time period during when the server was stopped. We also notice that the time difference between each event's scheduled time and the actual time of processing should get closer together as the server catches up, and within a few seconds, we're now back to normal with a time period of a few thousandths of a second between the event triggering the flow and the flow propagation recording the current time in the compute node ESQL. This concludes our demonstration of state persistence policies being used with the scheduler node.
Okay, that was all about state persistence policies. There's no let up today. We're going to keep going. So the next topic is all about ACE Open Telemetry. Just as a quick recap, we've provided a vast number of features in the area of open telemetry tracing over both the latter fixed packs and mod releases of ACE 12 and also inside ACE 13. This chart is just intended as a very quick recap of all that functionality. So you can see here that there are multiple different transport nodes that we provide usages of open telemetry in conjunction with. So we have HTTP nodes, we've got the REST nodes, we have SOAP nodes, callable flows, and most recently we've added Kafka nodes to that node set. In all of these cases, we're carrying open telemetry information inside the header of messages which are being exchanged. And open telemetry tracing is enabling us to see at a glance the amount of time or the span which is spent with inside different products. So you can see in the diagram at the bottom there, we have a pseudo ACE message flow that's using internally the OpenTelemetry client tracing library to send out these OpenTelemetry events to a collector, and then ultimately they arrive at an observability backend. So what we then added to the product is the ability to get access to the trace IDs and the span IDs, and you can see the full list of the 4 functions there, inside of a compute node as well. Now, typically, you wouldn't necessarily need access within your flow and inside your code, in the sense that OpenTelemetry with all of those built-in nodes is all handled for you. So as a flow developer, you're not responsible for having to copy forward those IDs. You switch on OpenTelemetry, they simply get transmitted on your behalf. But if there's an area where you'd like to get access to those detailed pieces of information, maybe to do cross-correlation with some other kind of activity that you're trying to do inside your flow, then having access to those values inside a compute node, we think is quite a handy thing to be able to do. So we've added those functions into a compute node to be able to access that data. Now, the new feature that's in 1306 is in a little bit of a related space. And what we're doing here is we're applying additional activity log tags, which include the OpenTelemetry trace information. So what this is really doing is recognizing when you're trying to debug certain scenarios, it might be useful to you to be able to go to the ACE logs, in particular the ACE activity log, that shows you all the activity of what the flow is up to. And then when certain events happen or when certain errors might occur, you could then look to see what those tag values are and use those to cross-reference with some other third-party solution that you might be using to collect together all of those OpenTelemetry events. Now, of course, there's no surprise why we might be doing this piece of work. This isn't just simply about a static connection for you. It's very cheap for us to offer these tags. But in the longer run here, what we're aiming to do is to then build on top of the OpenTelemetry work that we've already done and improve the dashboarding that we provide you with the product itself. So having these tags applied to these activity log entries is the first step that we need to carry out architecturally, so that in future you might be able to click one of these entries and then do a drill into the OpenTelemetry information as a result of what's been placed inside this log. So for the moment, a relatively simple, straightforward, somewhat easy feature to deliver, but just another item on this longer term journey that we're following with OpenTelemetry. So I'm sure there'll be more to come in that space in later calls of this type. Okay, we've still got a couple of demos to get through before our time is up today, so we're going to start setting the scene for those. And the remaining time today is really going to be spent on AI features. And in particular, we're looking at the deliveries that have actually come as part of our container offering, and they came at the end of January of this year. So we're now into the 13.061 content. And to ease us into that discussion, this first chart is making clear that we've made real big strides recently with what we're doing inside the ACE product in relationship to ACE. We have a pro code ACE assistant tool that we've demoed in previous calls that show you how you can generate ESQL inside the ACE toolkit. The mapping assist feature and the data assist feature are there for use with Designer when you're doing authoring. And in that context, it's helping you with that mapping task. It's providing you a percentage confidence of how two particular fields should be mapped together. Next, we're into the level of administration. And in that section, we're going to talk a little bit about agents. And agents are used in the realm of AI in order to automate certain processes without a human necessarily being involved. Agents are also often used as the underpinning to chat experiences. So in a couple of charts' time, we're going to see a demonstration of one of those chat experiences, which appears within the ACE certified container dashboard. Before we leave this chart, we're also going to talk in a few moments' time about MCP tools. And MCP tools have been added to the product in order to expand the way that AI can basically get additional value from your integration flows. So it's a really quick way of making connectors and existing REST APIs accessible to AI agents, whether or not those agents are provided by ACE itself or some third party. And we're going to show an example of that using IBM Bob, which is another technology that we're working on that should come out later this calendar month. So lots going on. I've not even mentioned the RAG pattern at this point. We have also got a pattern to carry out the retrieval augmented generation pattern of activity with AI. And again, we've talked about that in previous calls, so I won't dally any further on that one. So what are AI agents? Well, I hinted about this fact that typically an AI agent is all about behaving intelligently and being able to do things that otherwise a human might do on your behalf. And that falls into a couple of different buckets. We have MCP tools, which provide a standardized interface, somewhat similar to a REST API, which can take streamed HTTP inputs and using a JSON schema in a very ordered fashion, describe some tools that are available for invocation by an agent. And we also have agent-to-agent processes as well. Agent-to-agent processes are yet to be implemented within ACE, and we are looking at that area as well. But for now, our focus really with AI agents is all about model context protocol tools then being invoked by a standardized agent running inside of a container. And what are those containers like? Well, here we've got a number of different agents that are going to be running under the covers of App Connect Enterprise in containers. And you can see here that we've given them some convenient names. It's not really important to the user how many of these agents we have, or even precisely what we choose to call them. And what's more interesting is what their functions are. What are they there for? So in general, when you're using the chat assistant that we'll be seeing in a moment, you're essentially talking to these agents and then invoking maybe several different agents to answer simple administrative queries that you might have about your ACE system. And we're going to see that in action with a scenario. So in the video that we're about to play, we're going to see that chat experience, and we're going to join a colleague called Isaac, who is joining an integration team. He's going to be carrying out some admin tasks. So Aditi, when you're ready, if you could play us our next demo, that would be awesome. Isaac is excited to be joining his company's integration team, but as the newest member of the team, he's nervous to be learning all about App Connect Enterprise, which is the product used to host all of his company's integrations in a container architecture. Isaac notices a new agentic AI chat experience has appeared in the dashboard, so he decides to give it a go. I'm new to ACE certified containers. Could you tell me what an integration runtime is, please? Without having to go off searching the internet for documentation, the agent has neatly summarized the purpose of an integration runtime container. Isaac would like to apply this new knowledge and understand more about his company's architecture, with an eye on becoming an expert administrator, just like his colleagues. Having learned about an integration runtime, his next question focuses there. What integration runtimes do I have? In particular, can you tell me about anything which is stopped at the moment? On the face of it, the reply from the agent looks like good news. There are 8 integration runtimes that all have a ready status. None of the runtimes are stopped. Isaac's attention is drawn to the last one in the list, called IR Payroll. A few minutes ago, he'd heard someone pretty irate at a nearby desk, mentioning that the payroll application isn't available right now. Isaac suspects his confusion stems from not yet understanding all the ACE product concepts, so he asks the agent, what's the difference between an application and an integration runtime? The documented reply and links are helpful, and Isaac figures out that the application is the name of the artifact running inside the integration runtime container. Given this, Isaac's next question dives into listing the names of all the applications inside all the integration runtimes. This requires the agent to go beyond information which is recovered from the Kubernetes cluster level. Underpinning this architecture, these prompts from the user are being sent to an agent architecture that utilizes a couple of different LLMs which are deployed in the public IBM cloud using the watsonx AI service. The agents can also reach into the individual integration runtimes and report on the deployed artifacts. This reply has helped Isaac with a clear view of the product hierarchy. Runtimes host applications that in turn provide groupings of message flows. Scrolling down the response, Isaac notices that within IR Payroll, the payroll application doesn't seem to have any active message flows. His next question seeks confirmation of this by requesting a list of all the message flows, including their status. There's undeniably something not quite right here, as the message flow isn't running. So Isaac seeks some help with troubleshooting by next asking the agent to provide some possible reasons that could cause a message flow to not be started when it's deployed. Wow, this agent's pretty helpful. It looks like there could be quite a few different reasons why a flow might not be running. In particular, Isaac starts right at the top of the list and considers that configuration errors or dependency issues may be to blame. Isaac remembers that one of his colleagues was attempting to make some updates to the payroll application yesterday and wonders whether an important dependency may have been accidentally forgotten. After chatting with a colleague, Isaac discovers that the payroll application is pretty similar in its design to the HR application, so he goes back to the agent and asks it about the policy dependencies which are required by the HR application. It looks like the HR application uses an MQ policy to locate the queue manager that it uses when writing out messages. Next, Isaac asks about the policy dependencies of the payroll application so that he can compare. Sure enough, the payroll application has no policies. It's now time for Isaac to be the hero and go tell his colleague that the reason the payroll app is down is that the policy wasn't deployed. Flushed with his success, Isaac has another thought. He knows there's a plan to upgrade the HR application later today as well, and he thinks it might be a good idea to preemptively warn that department just in case there's any other problems. Isaac asks the agent to tell him what HTTP endpoints are exposed by the HR integration runtime. The detailed reply mentions the endpoint URL, so Isaac can use that information when circulating an email to warn users about which systems may be impacted. It's been a successful day, and Isaac has settled into his new team rather nicely. Before leaving for the day, there's time for just one more query. Isaac asks the agent to recommend some web links to help him explore more about IBM App Connect Enterprise. Maybe there are some other awesome features he could learn about to impress his new colleagues. Okay, I hope everybody enjoyed that little story there all about Isaac. We have one more demonstration to go, but before we get on to that one, I thought it might be nice just to quickly flash up an architecture picture, which is very similar to the one that you saw in the middle of that demonstration, but it just highlights where the containers are and how they're running, and gives me an opportunity to say that although that example was based upon integration runtimes deployed into our Kubernetes service inside the ACE certified container offering, we are intending in future to also hook that up to on-premise integration nodes and integration servers as well. So you can see some items marked in grey on the chart. It is our intention to include those in the scope of these sort of administrative features that you were just looking at in future. That's not there right now today. Right now today, the offering as it stands is in tech preview and is likely to become fully production supported at the end of this month as part of that container offering. So the last topic today is really all about model context protocol servers. And as we mentioned briefly earlier, these are a capability that enables AI-driven applications to easily exploit existing services that are already running, that are already part of traditional software products. So what the MCP server is doing in the ACE context is it's enabling you to get access to an integration server, which might be for a couple of different reasons. The diagram as it's currently shown on the right-hand side is showing kind of admin connections. The pink arrow is an admin question that's being posed to the integration server about what's deployed. We've just seen some examples of how that could be used. But what we can also do is expand the MCP server's capabilities to also be able to invoke message flows as well. And they could be invoked directly across an MCP tool by an AI agent. And here stuff gets really quite exciting. It gives us some possibilities to do all kinds of different things with an integration server. We have an example here showing an integration server. That's what this gray box is. And the first kind of flows that we're going to invoke over MCP are those that relate to connectors to third-party applications. In total, we've got some MCP tools that can talk to 2,800 or more connector objects and actions. We're going to see an example of that in the video that we're going to finish with today in just a moment. The next thing that's likely to come along, and as it says here on the chart, coming very soon, is to then also expose existing REST APIs that you may have authored and deployed to ACE as MCP tools. And we're working on that right now and expecting that to be part of our 13.07 deliverable. So I'll probably be talking about that the next time we speak. And the last two are future considerations. So we may also start using MCP input and reply nodes as part of a development task. You can drag and drop those into a flow, and you could create a new artifact from scratch that you want to then expose as an MCP tool. And again, another future consideration, we might start looking at message flows which don't necessarily relate directly to that request reply sort of style. So maybe you've got some MQ-driven message flows that you would like to expose as MCP tools. We think we could probably do that via the use of one of these features that are shown here. So maybe get from the user an example of what the schema should look like and what the tool description is, and then we'd go forward and create those kind of tools. So the very thing we're going to do now, we've got one demo left, and this is going to show an example of using MCP tools to connect and expose connector REST APIs. And after that, we may just have a couple of moments left at the very end for some questions. Aditi, could you play the last demo, please?
This demonstration starts inside the ACE Certified Container dashboard, and there's a new icon and menu option on the left side called MCP Servers. To begin with, we've only got one MCP server showing, and through this demo I'm going to create a new one from scratch. There's a radio button displaying two options, one for future expansion and the other to expose connectors as MCP tools. On the next page, we provide a name for the MCP server and specify that the IR needs to be started at the latest version of 13.06.1, and we're going to stick with the licensing defaults provided. Underneath the wizard, the dialog explains that we're now about to create an integration runtime, and typically that might take 2 or 3 minutes to complete. So there's a warning about that in the recording, and there's a disclaimer to note that in reality this step of the wizard may take a little longer. So under the covers, that integration runtime has now been started, and it's serving up some APIs that the user experience can exploit in providing selections for a huge number of existing connectors. It's worth noting that I'm not showing a flow experience here. I'm just simply choosing which one of these endpoints I want to connect to. So in this example, I'm going to pick a couple of different endpoints. The first of those is Salesforce, and that requires me to have some credentials. And with the power of a pre-recorded video, I don't have to watch a lot of typing here, as if by magic, all of my credentials have appeared, and those credentials are nicely obfuscated so nobody can steal them. On clicking the Connect button, we're going to go off to Salesforce, check those credentials are successful, and when they are, we'll see the pop-up in the top right corner of the wizard. Now, if we scroll back up to the top of the dialog page, we'll see that we've now got an account that's been created on our behalf and a wider number of different objects and actions that are available within Salesforce. In due course, we're going to pick a couple of those, but the next thing we're going to do now is set up a second account connection, this time to Slack. So we've used the filter option at the top of the dialog to sort through those many connectors. And in the case of Slack, we just need an access token that we can paste into position and then attempt to connect. Of course, to get that access token, you will already have gone through the OAuth experience in order to get the credential needed in order to connect successfully. So we've now got a couple of applications connected, Salesforce and Slack. And if we expand each of those, we can then make some decisions over the kind of actions that we want to expose as MCP tools. In the case of Salesforce, we've picked 4 different actions against contacts. So that's create, retrieve, update, and delete. And we're going to do a similar thing with the leads inside Salesforce as well. So in total, we've now got 8 separate selections, all against the Salesforce application. In the case of Slack, we're going to look to retrieve a list of public channels and the ability to send a message through Slack as well. So in total now we've got those 8 plus 2 separate actions, 10 in total, which we're going to carry forward to the end of the dialog. On the last page of the wizard here, we're shown a quick summary of the available actions that we've chosen, and then we're going to go ahead and create the MCP server. The process of spinning up that integration runtime, again, can take a couple of moments. So we've got a disclaimer shown in the wizard there, and also the warning that we've placed on top of the recording that it could just be a little bit longer in this stage of the wizard. So having completed that process, we can see now that on the dashboard, I've got a couple of different MCP server options. There was the one that we started with and the new one that we've created. And you can see the basic properties include the URL where the server is hosted, and also a username and password that can be used as basic auth credentials in order to make secure connections. Flipping to the MCP Tools tab, we can see that same list of tools that we've just made the selections of through the wizard. So the next thing we're going to do here is copy the URL and paste it into an MCP inspector tool. We're going to add in here the basic auth credentials that are required in order to securely connect to that server. And then using this independent tool, prove that the tools that we just created are now available and exposed for other applications to invoke. So having filled out that authorization header, we can then scroll down the menu on the left-hand side of the inspector tool, click the connect button, and then we'll be shown a list of the available tools in the center panel. We can see the create, delete contacts, retrieve contacts, etc. And then also the actions revolving around leads. And then at the base there, also the do from Slack. So the retrieving of public channels and the sending of a message. So this gives us a good sanity check, if you like, that the tools have been successfully exposed. But we're actually going to invoke these tools from a different interface, and we're going to switch now to IBM Bob. When interacting with MCP servers, Bob requires a very small snippet JSON file to set up those connection details, which I'm not showing in the video here. But having done that, we can ask a simple question. Hi Bob, can you please list my MCP tools? And you can see that Bob is coming back here with a suggestion of those tools that have been distinctly separated according to the object inside the 2 different applications. So we can see the Salesforce contact tools, the Salesforce lead tools, and then the Slack tools at the bottom. So we're now going to attempt to use those tools. So the next question, always be polite to your AI agents. Can you please retrieve my Salesforce contact? And I'm going to qualify that with the last name Kane. And many folks will know my demos typically involve soccer players, football players in the UK, and in particular those that play for my team Tottenham Hotspur or have done in the past. So we're going to retrieve information about Harry Kane. And here's one of my Salesforce contacts. So when I click that approve button, we've got auto approving disabled in this example. So you're going to see my mouse go back to that blue button several times in the demo. And after a few moments, that will come back to us and it's successfully retrieved that information. Now, the impressive thing here, of course, is that we've not mentioned anything about ACE. We've not mentioned a message flow at this point. We've simply gone off and written a human worded question to retrieve that item from the back-end application without our middleware even being visible at this stage. So lots of good information there. We can see he's a striker, we know his mobile phone number, got a description and so on. What we're now going to do is then retrieve all of the available Slack public channels. So we're going to ultimately take the data about Harry Kane and put it into Slack. But before we can do that, we need to know what those channels are called. And if anybody's written message flows that interact with Slack, you'll know that Slack channels typically have rather horrible internal IDs. You can see a few of them listed here under these 3 different channels. We're in particular interested in the general channel. And so we can then refer to the general channel just by its name rather than having to type out those horrible IDs. So having looked briefly at the Salesforce channel there without any messages in it, we're now going to ask, can you please send the Salesforce contact? In this case, it's the one that we just retrieved, and we're going to ask that to be sent to the Slack channel that's called General. So that's going to take that data, it's going to format it for us, it's going to send it off, and then we'll be able to return to the Slack channel and see that that data has genuinely made it where it was supposed to go. So the tool here has interpreted which one of the MCP tools need to be invoked. We're going to click that blue approve button once more, and then under the covers that works on then sending the data off to Slack. We've got a success message that's come back in confirmation, so we can see all of the various bullets there regarding the different parts of the information about Harry Kane that have been posted. And then if we go back to the Slack channel now we can see that data has all been passed through successfully. The final section of today's demo is really more for the propeller heads in the room. We're returning to the ACE Certified Container dashboard, but this time we're going to look at the traditional view of the integration runtimes and then drill into the demo MCP IR that we created. We can see that we have a new tools panel showing the tools that have been exposed, but more interesting is on the contents panel, we can now dive into the individual applications that have been created to provide the tools. And we note that there are MCP input and reply pairs, which is a look into the future ways that we're going to be supporting MCP with the products.
Okay, and I think that takes us to the end of that demo. And so I've only got a one chart left, and it's just giving us the chance in the last couple of minutes to wrap up and cover off any other questions. I think I've managed to get most of the questions that have come through the chat interface answered for us today. There are a couple that are remaining. So one is asking about whether there is any new offering for financial institutions with ACE 13. I think this has come from potentially an FTM product user, which of course is built on top of ACE and some databases. I don't think there's anything that I'm aware of that's quote new in that game. Obviously, support for the newer versions of those core products on which FTM is based, but nothing in terms of an entirely new offering in that space. So if there's something in particular that you're after there that's not resolved through FTM, then yeah, please do let us know. Always interested in new ideas for new products or indeed new features. There's one other question which actually relates to something that we've not been showcasing today, and that's the code assistant that's inside the ACE toolkit for helping out with the ESQL examples. There's been a couple of questions fly by about that particular topic, even though it wasn't our main focus today. It appears that there are some situations where folks might get so-called pseudocode outputs from that tool. And I answered one of the other questions on that point. Essentially, when you frame the prompt to that tool, sometimes it's really helpful to clearly qualify it as ESQL inside App Connect Enterprise to avoid confusion with traditional SQL for databases. That being said, sometimes LLMs do hallucinate, so there can be no guarantees on this kind of thing. But that's the most likely issue I think we have there. There's one other question that's just come in regarding the AI agents and whether they're part of the ACE licensed or separately licensed. At the moment, the AI agent is part of a preview, and you can go to ibm.biz/ace-agents, and there's lots more information there around the licensing position. Essentially, these are currently available for anybody to download if you already have entitlement to ACE. When we ship the capability at the end of March, it's likely that will just be rolled into the standard part of ACE certified containers. At that stage, whether or not there's a separate license to accept or a separate button to click on, that will come to the minutiae of the deliverable. But expecting that one to be pretty much business as usual, although you will have to buy separate entitlement to the LLMs hosted up in the public cloud in IBM's Watson X AI service. Again, more information about that on the website. With the last little flurry of questions, I think we've managed to get through everything today. So thank you very much for joining us. Thank you very much for giving me your time. Hopefully I will see you again soon. And with that, Aditi, at your leisure, if you could please close us out and disconnect. Thanks everybody for coming.